my loves. All right, so today we are doing lesson 75, which is all about measuring turns. This is one of those things where, again, it would be really nice if we were in the classroom and I could show you in person how this works. But I think I might be able to use my phone to show you how we do this, okay? So as you may recall from a couple of lessons ago, we're starting to do some transformations with our geometric shapes. So turning, rotating, flipping, translating, all that nonsense. So this one is going in specific detail with rotations. And in this chapter, it actually does call them turns. So I'm going to call them turns just because it's easier. When we turn a geometric shape, we turn it a certain amount. Like maybe if I take my phone, for example, maybe if I turn it, I'm going to turn it just a little bit. Or maybe I'm going to turn it, all the way down. And we measure how far we're turning something by degrees. Not like Fahrenheit degrees, but we do use the same symbol. And yeah, I don't know why it's also called degrees now that I think about it. But anyway, if something turns all the way, so for example, here's my starting point, if I turn my phone all the way around until it's back in the spot where it started, that is called a full turn. That's a full 360-degree turn. If I do a half turn, so I go from here to right there, that's a half turn. That is 180 degrees. And a quarter turn, if I'm starting here, is just going 90 degrees. All right, and here is a picture that shows you a full turn is going all the way around, a half turn is going halfway, and a quarter turn is just going a quarter of the way. You might look at this and think to yourself, this looks kind of familiar. Where have I seen something like this before? Well, you've seen this every time you've looked at an analog clock, at one of those round clocks with the clock face. That's the exact same thing. If we go a full turn around our clock, that's 1 full hour. If we go halfway, that's half an hour. If we only go a quarter, that's only a quarter of the clock. I also bring up clocks because when we turn, we are either turning clockwise or counterclockwise. I'm not going to show this with my phone just because I think my camera will flip it and have me going in the wrong direction. But basically, when you do a clockwise turn, you are turning in the same direction that a clock hand goes. So clockwise is going in that direction. Counterclockwise is going the opposite direction, 12 to 11 to 10 to 9 to 8. So there's clockwise and counterclockwise when we are turning. The time when it really matters to know which direction you're turning is usually when it's to do with quarter turns. If you start at the 12 on the clock and you do a clockwise quarter turn, if you start at the 12, you're going to end at 3. But if you do a counterclockwise turn starting from the 12, you're going to end up at 9. So those are two very different places on the clock face. So whether you're going clockwise or counterclockwise, it matters a lot when you're doing quarter turns. So let's move on with that information to our question. Maria and Irina were both facing north. Maria turned 90 degrees clockwise, and Irina turned 270 degrees counterclockwise. After turning, in which direction were both of the girls facing? Maria turned 90 degrees clockwise. So, like I said before, if someone's turning 90 degrees, that is a quarter turn, and she's going clockwise. So if you think about a clock, then you're starting at the top and you're going in the direction of the 3. So in this case, Maria is now facing east. Irina is turning 270 degrees counterclockwise. I did not mention 270 degrees earlier because that's not considered one of the 3 main turns. There are easier ways, as you are about to learn. But to do this, all you need to do really is just kind of add up turns. So, for example, a quarter turn is 90 degrees. If you add 90 plus 90, that's 180, which is a half turn. If you add another 90 degrees to that 180 degrees, you get 270 degrees. So Irina is literally going from the top. She's going counterclockwise. She's literally going from the top all the way 90, 90, another 90, and she also ends up facing east. They are both facing east now. But like I said, 270, it's easier to just go 90 degrees in the opposite direction than go 270 degrees and go through all that work and go all the way around. That's just silly. So usually people just do the 90 degrees. Number 2, describe the amount and the direction of a turn around point A that would position triangle 2 on triangle 1. That little dot there where it says A, that is point A, and we are going to be moving triangle 2, the one on the bottom, so that it is positioned on top of triangle 1, the one that kind of looks like a shoe. We're not moving the triangle at all. It's still hinged onto point A, like when I was doing with my phone, like this is the hinge point. It does not move from that point, really. We already know that we're going to be turning it, we're going to be rotating it, and they want to know by how much are we going to be turning and rotating it. So let's pretend that this is my triangle. I know it's a rectangle, let's pretend. And this is point A up here. What am I going to do to make it look like a shoe? I'm going to do that. And that is considered moving it 90 degrees counterclockwise. So the answer is we need to rotate triangle 2 90 degrees counterclockwise, or just say 90 degrees counterclockwise. And then this last one that I just want to kind of do, just to, drive it home. Describe the rotation that would position triangle 1 onto triangle 2. So again, we have a point, and this time it's also point A, that is hinging our triangles together. How much would we rotate triangle 1? So if we, let's see, which way do we want to go? I want to go clockwise. I don't know if it's going to show up clockwise when I do it with this, but pretend I'm going clockwise. 90 degrees. My triangle is now upright perfectly. It is not on top of 2 yet. So I'm going to move it another 90 degrees. I've now moved it 180 degrees, and it is now on top of my other triangle. For that one, I would write my answer as 180 degrees. With that one, because it's 180 degrees, because it's a half turn, counterclockwise or clockwise would work, because no matter which way you go, you would still end up on top of the 2, triangle 2. So like I've said before, I really don't like these lessons where there's like shapes and turning them involved, and I don't have actual shapes to turn and show you. I hope that made some sense. If not, let me know, and I'll try to do something to help make it make more sense. Go ahead and give lesson 75 a try. As far as I can tell, you should be pretty good with it. Just let me know if you need any help. Yeah, okay. All right. Bye.